Hi all, I'm Letian from SPM paper, and in this video I'll explain the 2020 Kelantan AddMath trial paper 2, question 1. So given quadratic function fx equal to 4 minus 3x minus x squared, the question asks us to use completing the square to find the maximum point of the quadratic function. So completing the square actually means if you are given a quadratic function in this format, ax squared plus bx plus c, want to convert it into the completing the square form that look like this. A multiplied by x plus d bracket square plus e. This is the complete square form. So you notice there's a square over here. That's why this form is called a complete square form. The reason we want to apply completing the square to get into this form is because we want to easily find the maximum or the minimum point. Like after I convert the equation into the form a multiplied by x plus d squared plus e, right? I can easily identify the maximum or minimum point as negative d and e. So notice that I have to add a negative sign in front of the d, but I don't need to add anything in front of e. So this is the completing the square. So now let us apply this to our question. So given the equation fx equal to 4 minus 3x minus x squared, we can rearrange it into the ax squared plus bx plus c form like this. And then we can start our completing the square operation. So normally the first step is I factorize out the negative. The reason I want to factorize out the negative is because in front of the x squared coefficient, there's a negative sign. So normally we want to make the sign in front of x squared to be positive. So we factorize it out. X squared, negative 3x become plus 3x. And then plus 4 become negative 4. And then the second step is I call it plus b over 2 square minus b over 2 square. So what do I mean by that? First, we need to know that the coefficient in front of x squared is a, coefficient in front of the x is b, and the constant is c. So b basically is 3. To apply the step 2, right, we just copy it like normal first, x squared plus 3x, and then we leave some space, negative 4. And at this place, we put in our plus b over 2 minus b over 2 square. So plus b over 2, b is 3, so 3 over 2 square minus 3 over 2 square. So for this part, right, because we add and minus the same number is still equal to 0. So it's still the same thing as the line above. The reason we want to add b over 2 square minus b over 2 square is because we want to get this part, so that we can get something like this. X plus 3 over 2 square. So you notice how the above equation with 3 terms, it can become 2 terms below. The one highlighted in green, they're actually the same thing. If you expand x plus 3 over 2 square, you get back the terms above. So the next step, we copy back the thing above, negative 3 over 2 square minus 4. Then we multiply back the negative into the bracket. We get negative x plus 3 over 2 square plus 3 over 2 square plus 4. So the final form is x plus 3 over 2 square plus 25 over 4. So this is actually in the form of ax plus d square plus e. And remember, the maximum point or the minimum point is negative d e. This is why for this question, the maximum point is equal to negative 3 over 2, 25 over 4. So now let us move on to the part B. Part B asks us to sketch the graph for the domain negative 4 to 1x. So for graph sketching, right, normally the first step I do is identify the maximum or the minimum point. So in this question is maximum point because the question already tells us it's a maximum point. So from the previous part, the maximum point is negative 3 over 2, 25 over 4. Then the second step is, want to know is a crying face graph like this or a smiling face like this. So to differentiate this, basically crying face, you notice is a negative x squared. The smiling face normally is positive x squared. Also, we know that for crying face, this is max point. And for the smiling face, this is minimum point. So in this question, you notice the x squared here is negative. So for this question, it's a crying face because it's a negative x squared. It's also consistent with the question tells us it's a maximum point. So it's a crying face. The third step, we find roots. So the roots you can find by factorization. The fx equal negative x squared minus 3x plus 4. Factorize out negative x squared plus 3x minus 4. Factorize it further, x plus 4, x minus 1. So we know that for roots, right, the fx is equal to 0. So the roots is x equal to negative 4, x equal to 1. If you are not sure how to factorize, you can also use this formula to find the root. X equal to negative b plus minus b squared minus 4ac square root 2a. Or you could also use the calculator function to directly find the root. So now I already gotten the roots. I want to find the last thing, which is find y-intercept. So y-intercept is when x equal to 0. Substitute in x equal to 0. 0 minus 0 plus 4. So the y-intercept is 4. Okay, after we have all of this information, we can start plotting the graph. So for the graph, there's a y-axis, there's an x-axis. And then the first step, we plot the maximum point. So the maximum point is here, -3/2, 25/4. And then the second step is a crying face. It's a crying face. We draw a crying face over here. And the third step, the root is -4 and 1. So we can plot the root here, -4 and 1. And lastly, the y-intercept is 4. So the y-intercept here is 4. Now we can check back the question again. The question says the domain must be x between -4 and 1. So this is the domain. It's the domain. It must be between -4 and 1. Which means if just now I accidentally draw the graph slightly longer, like this one will exceed the domain. Let's say if I were to draw the graph exceeding the domain, I may be minus marked by the teacher because I did not read the instruction properly. So we must be extra careful to ensure that the graph must be lies within domain. So rub this off. And then now we can move on to part C. Part C is take the range of fx. Just now we already know that the domain is horizontal axis. So what about range? Range is the vertical axis, is the range. We extrapolate this. The top of the range is 25/4 and the bottom of the range is 0. So we can say that the range is fx between 0 and 25/4.